So the traditional budgeting tools like the bank apps only offer like static numbers like the category totals, but they don't explain patterns like identity relationships or adapt analysis to a user's question. So based on this, we designed this website like to address this gap and provide the user with tailored and valid financial insight. So our goal is to design a financial analysis tool based on bank statements to bridge the gap between raw transaction data and meaningful financial insights. The WellSight will generate the valid financial insight summary, like the tips, like the clear dynamic visuals that will be tailored to every user.
And now I'll start to introduce the system architecture, starting with the input layer. The input layer actually defines what WellSight needs. So at first, we need a natural language query from the user. It has to be financial related. And the error handling part, I'll introduce that later in the processing part. It will use show me breakdown of my expenses on food and drinks last month as an example for the whole system demonstration. The other thing we need is actually the banking statements in CSV format, while the CSV format always should contain date, description, amount, and optionally bank. If not, the system will ask the user again for the corrected formatted CSV. And moving on to the processing layer, as you can see, it contains of two agents. The first one is the statement classification agent, which classifies each transaction to the best match detailed category, to look up the primary category in the reverse way according to our play taxonomies, which I will introduce later in the data part. And also, it will map all the merchants and the type for the transaction to fixed and variable, and everything will be mapped based on the description for the transaction. And here's an example if the description is Visa purchase stop loss, and these are all of the fields that can be mapped. And then everything of the data frame and the user query will be sent to the conversation interpretation agent, and based on the classified data frame, it will understand how the system can answer tailored to the user's request. It will also detect non-financial queries and handle the errors, prompt the user again for the input. And as you can see on the screen, it's actually showing a response of the result, where action and a metric are actually the outlines about how the system will do will process with the downstream analysis. And action contains summarize, breakdown, compare, and analyze, and metrics contain about the 4 fields as shown on the screen. And then we'll go to the analysis layer, which is the key for WellSight. In this part, we have two agents as well. The hypothesis agent is actually the manager agent. It does not touch the raw numerical features, but only touch about the categorical features and the user query. And insights analysis agent is actually the worker for the analysis. It does not touch the raw categorical features, but only touch the numerical features. Two agents also implementing different models for eliminating the bias. As you can see on the diagram, as soon as the hypothesis agent generates a hypothesis, it will send to the IA, and the IA will calculate everything based on only numerical findings. And all the numerical findings that question and answer pairs will be sent back to the hypothesis summary phase, which will actually generate 3 blocks. The first one is a paragraph summary. The other one is tips in bullet points. The third one is some supporting visual diagrams. And then we'll go to a streamlit tools and then generate the final output dashboard, which is just like this. On this screen, as you can see, the summary and insights were actually the paragraphs and the bullet points, and the visuals were actually the models that the agent think will help the users to understand more about the transaction details. More thing about the data, so we use the play taxonomy as the only knowledge base for the RAG, and then it has 16 primary categories and 104 subcategories. So no 2 subcategories share the same primary category, which means that we can just map the details to the primary. And for transaction details and user queries, these are actually the testing data, and the description is actually shown in the detail columns here. And everything, these data are actually used for the downstream analysis on the measure of success, which is the quantitative part. So we will have 3 metrics: the query understanding, classification accuracy, and the output calculation accuracy, which is corresponding to CIA, SCA, and IA. The evaluation method will be just creating a pipeline and for simulating the input and testing the accuracy for this output. As you can see, the results are actually pretty similar, are pretty well, but sometimes the query understanding and classification accuracy contains some of the things caused by the ambiguous taxonomy, such as food and drinks and to general merchandise convenience stores. And also sometimes the model may call the wrong tool in the output calculation accuracy.
So to understand how well it works in practice, we also run a small usability test with 10 volunteers. Like each person uploaded a sample bank statement and rated WellSight on 3 dimensions: the relevance of tax insight, uniqueness or added value, and the visual layout, as shown here. For the feedback results, the general performance is acceptable, except the uniqueness of insight. WellSight only got a 3.5 out of 5 score on it. Some participants said that WellSight pointed out something they could have spotted themselves by quickly scanning the statement. We also looked at a concrete failure case. The user asked what my food and drink grocery spending in March this year. The expected output should have been a breakdown of spending in food and drink grocery categories only, but the system just returned a breakdown for general merchandise convenience stores. This happened because of an ambiguous taxonomy definition. Multiple merchants were mapped in broad categories. So the query put in the wrong group. This single mapping issue then triggered a chain reaction of downstream analysis error. Overall, the discussion around our result was quite reasonable. So quantitatively, the system meets many of our technical goals. For example, multi-step reasoning works well with COT prompts. Qualitatively, the user feedback also makes sense. The model currently relies on fixed prompts and generic logic, so the insight can feel repetitively and not very novel. So if we were to design this project again, we would do 3 things to maximize the development efficiency, like refine the taxonomy first and then prototype with fewer agents, and finally run usability tests early in the design process. Thanks, that's all.